Okay, welcome to lesson 1.3, and we're going to take two-step equations that we've been reviewing and learning about in the first two lessons and apply them to word problems. So these ones in the warm-up you should have done in 6th or 7th grade. They are one-step equations. See if you can write an equation for each of these and then solve it. So a car travels 40 miles per hour for h hours. So first of all, we're using the variable h. And what is the rate in this problem? What is the rate of speed? The rate of speed will always be your coefficient. I was not kidding when I said coefficient is the most important word or vocabulary word of the year. I'm going to say do this to the coefficient. You better know what it is. So the rate here is 40 miles per hour. That's our rate of speed, and the rate of speed will always be your coefficient. You can write a problem where it's not, but we're not going to do that. Your rates are your coefficient. The car traveled a total of 4,000 miles. That is the one-step equation that covers this situation. And in 7th grade, you should have been drawing graphs that started here and showed how the car is moving, and this should have been hours and this should have been miles, because that is a 7th grade standard. And the equation of this looks like this. So in 1 hour, right, we go 40 miles, and in 2 hours we go 80, in 3 hours we go 120. To solve this equation, we're going to divide both sides by 40. Now, major trick, when you have zeros there at the end, you can cross out those zeros. And so this is the same as 400 divided by 4. And so to go 4,000 miles, it's at 40 miles every hour, it's going to take 100 hours. All right, 100 times 40 is 4,000. Try the next one. So what's the rate in this problem? $4 per pound. The rate or cost of apples is $4 for every pound. So we're going to use P for pounds. Please use the variable that I specify. That way we all get the same answer. And so the rate is the coefficient, and we spent $20 on apples. If we divide both sides by 4, if we spent $20 on apples, we must have gotten 20 divided by 4, or 5 pounds. Notice these were word problems. They had words on the answer. Now you can abbreviate. The abbreviation for pounds, LBS. Abbreviation for hours, HRS. So those are one-step equations. We're going to be doing two-step word problems. Now in a two-step word problem, the rate, that's what this R is standing for, will be the coefficient of whatever variable we're using. I put X in the example. The constant on the same side as X is going to be where the problem begins, where it starts, the thing that already happened. And that's the difference between these problems and the ones you may have done in 6th and 7th grade. And notice, just like in the warm-up, the total amount of hours or dollars is always going to go over there. So let's see our first one. The student council raised a total of 150. All right, so the total goes over here every time. During a charity dance, they charged $3 per ticket. That's our rate. The rate is going to be the first thing we write, the coefficient. We're not going to use X because it says we're going to find how many tickets they sold. So 3 times T. T stands for tickets. And notice we received $24 in donations already. That's the constant, the thing that already happened. We already received that, right? The past tense is a big hint there. So that's the two-step equation. And in your homework, there's going to spot where it says write the two-step equation, and then you're going to fill in another blank which has the solution, right? And so the solution part should be easy, right? Because these are nice and easy. We subtract 24 from both sides. 3t equals Let's do a little borrowing, and we get a 6, and 13 minus 2, well, 3 minus 2 is 1, so we get 116. Oops, I've done something wrong, have I not? And so let's see what happened. Oh, because we borrowed from there and made it a, right, we borrowed from there and made it a 4, so it's 126, not 116. Thank you. Divide both sides by 3, and t equals 42. Now, it's a word problem, so what does that mean? The solution here is 42 tickets, right? At $3 per ticket, they sold 42 tickets, plus the $24 they got in donations, for a total of 150. So we're going to do a whole bunch of word problems, but they all follow that same pattern every single time. All right, so Larry needs 75 points on his final exam to pass his science course, right? That's his total that he needs. It's not always going to be the first thing in the sentence, by the way. You can't do shortcuts like that. He received 43 points on the first half. That already happened. He received that already. And by the way, this is almost always going to be plus. It's really hard to write them where I can put a minus there. So those are almost always going to be plus. And each question on the second half is worth 2 points per question. That word per is a dead giveaway. You have a rate, like miles per hour, dollars per pound. And that is going to be our coefficient. And the variable here is questions. We want to know how many questions he has to get right to get exactly a 75. Now, in reality, he probably wants to get greater than or equal to 75. We'll talk about that on another day. But let's assume he wants to get exactly a 75. So that's our equation. So you're going to have to write that. You cannot do it some other way. And now we're going to find the solution. We're going to, right? So that's the hard part. Subtract 43 from both sides. 2q equals 5 minus 3 is 2, 7 minus 4 is 3, divide by 2, and q equals 16. So the solution here is 16 questions. And notice, this is a big deal in algebra word problems. You don't want to use x for a word problem. All right? You want to use the letter, because you have to write this word at the end and know what you're talking about. You want to use a letter that reminds you, oh, I'm finding the number of questions he has to get right. Please do that. So now, units, right? We just talked about units, miles or hours or whatever. You can actually do problems and figure out things just by looking at units. And that's what this little screen is trying to show you. A car travels 50 miles per hour and has traveled 125 miles already. How long in hours will it take to travel 4,000 miles? So let's write this all out. So it's 50. Now, we're not normally going to do this. We're just doing it for this one example. 50 miles per hour, right? So in 6th and 7th grade, you wrote miles per hour that way. That's our rate. Times the number of hours. So h for hours. So I'm writing that's the variable, and that's the amount of, that's the units on hours, h for hours. And we're adding to that 125 miles. And it equals a total of 400 miles. So that's the equation with all the units written in, right? So notice what happens. We subtract 125 miles. It says solve the equation here. That's what I'm doing. Subtract 125 miles from 400 miles. These cross out. And over here, you're borrowing, right? You're making that a 9. And that's 5, 7, and we're getting, I borrowed, so 275 miles over here. Now, look at this. This is 50 miles per hour times h hours, right? Just like you cancel fractions, those hours cancel out. They do. And so we get 50h. So you can see, whoops, I meant to write miles in here. So there's still miles left. The hours of the h is still there, but the miles is still there. 50 miles times h, right? You divide both sides by 50 miles. And notice, right? All that's left is H, and 50 goes into 275, right? It goes 5.5, and what's left? Hours. Okay, so the harder version of these word problems do not have the rate in there. So let's see this. Apples cost $16 for 8 pounds for an 8-pound bag at the local price club. So what is the cost of apples? Well, the cost of apples is $16 for 8 pounds. So this is a little 7th grade work here. And so that is what? $2 per pound, right? So the rate here is $2 per pound. Now, right, the rate was not given in the problem. There are going to be some like that on the test, right? You have to understand what a rate is. It's dollars per pound, miles per hour, dollar, and so that is going to be 2 is going to be our coefficient, not 16 or 8, right? And we're doing P for pound, so it's $2 per pound. It says include the units. There's the P, which is pounds, right? And then what did we have to pay? We had to pay $50 already, okay? And we have a total of $58, which we're going to spend. The total is over here, what we already spent. This is like Costco or Sam's Club. You have to pay a membership fee. Now look what happens to the units again here. The units, the pounds cancel out, and we have dollars, dollars, and dollars. That's what happens. You subtract 50 from both sides, you get 2p equals 8, divide both sides by 2, and p equals 4 pounds. All right, the dollars all cancel out, right? Dollars divided by dollars cancels out. Now, normally you don't have to put the units in, so let's just start doing some examples. The county fair is $4 for 8 rides. So what's our rate? It is $4 for 8 rides. So what's the rate here? It is $1/2 per ride. Now we don't usually say half a dollar, right? We say 50 cents per ride, but either way, all right, that's our coefficient. So you could write this as 1/2. We're going to use R for rides. Now, what does everyone pay to get in? What did everyone already do? They already paid $10. And we have a total of 32. So both of these, right, I'm going to eliminate the 0 and 50 cents. Both of these get the same answer. You don't have to solve both of them. Pick one. Right, in both of these, you're going to subtract 10 from both sides. Right, and here you get 1/2 R equals 22. Here you get 0.5 R equals 22. Here you multiply by the reciprocal and get R equals 44 rides. Wow, that's a bargain. Yeah, because these rides are 50 cents each. That's really cheap. Rides at real fairs are more like $3, $4. And so now notice those who love decimals, one of the reasons I include this problem, right? You have more work to do. Those who love decimals, you have to do 22 divided by 0.5, right? We can't have 0.5 out there. You have to fix that and make it 5. What happens? Then you move this over and make that 220. And yes, you do all that work and you will get the same answer, R equals 44 rides. Do not be in love with decimals in algebra class. Fractions are often faster. Okay, now the rate can be a negative number, okay? This is always going to be plus. Those who, right, the rate is what changes to negative here. So let's see that. A candle starts at 10 inches tall and burns 2 inches per hour. All right, so the rate is 2. So that's our coefficient, you would think, right? The rate is 2. But if you have 2 positives there, that would mean the candle is getting taller by 2 inches every hour. And the candle is not getting taller by 2 inches every hour. It is getting shorter. So this is negative 2h. The candle started at 10 inches. That's what always goes there, where we started, what already happened. And it burns down to 3 inches. Now notice what's also tricky about this is that usually the biggest number is over there on the total. But that's not true because we're going down. The total height of the candle at the end is 3 inches. So please, some of you are going to be tempted to write this as 10 minus 2h. The students who do that often get confused later. All right, all you need to know here is the coefficient is negative. Then you solve it the normal way. So negative 2h equals 3 minus 10, negative 7, right? Not 7. Divide by negative 2 both sides. Notice what happens. The two negatives cancel each other out, and you get 7/2. Now, no one says time is 7/2. So normally, yeah, 7/2 is a perfect answer. But normally, we would say 3.5 hours. I want everyone to write that as minutes. All right, that would be 3 hours and what? 30 minutes, right? Right? If you write that as a decimal, you'd write 3.5. Another problem with decimal points. Decimals are in tenths, hundredths of thousands. Minutes are in 60ths, right? A minute is divided into 60, or an hour is divided into 60. So they don't match up, right? 5 turns into 0.5 is half an hour, 30 minutes. So be careful of that. So 3.5 hours, or 3 hours and 30 minutes is what I would be looking for here. But this problem is here. Anytime things are burning down or falling down, you're going to have a negative coefficient. All right, this is another one with a negative coefficient, and this is literally the hardest one we do. An oil company's drilling a hole, right? They drill down at 2 feet per hour. It doesn't say that, but we're going down 2 feet per hour. They're currently at 5 feet above sea level. Write and solve an equation to determine how long it will take them to drill to 30 feet below sea level, right? That means negative 30. So the rate is down to every hour. I didn't say to use h, but this is feet per hour. We started at 5, and we're going to end at negative 30. Our total is negative 30. That's the equation you're solving. Subtract 5 from both sides. Negative 2h equals negative 35. Divide both sides by negative 2, right? And this is, right, you could write 35 halves normally, but 34 halves, right, is what, 17. So this is 17.5 hours, or 17 hours and 30 minutes. The key is we're drilling down 2 feet per hour, so you have to put a negative there. It's 30 feet below sea level, so that's a negative 30. All right, so practice. Do these problems and then check your work. Peter was a waiter that was paid at a rate. So that's a very easy one, right? Because it's 8, the rate, it says the word rate. You know that's your coefficient. He earned $54 in tips. He's already earned that. It already happened. And he earned a total of 200. That's the equation. We're subtracting 54 from both sides. 8h. We're going to do some borrowing here. And divide both sides by 8. Is that right? Yes. 8 goes into 14, once. And 8 goes into 66 8 times. Remainder 2. All right, now I'm going to make a decimal. Decimal straight up. Oh, you could make this a fraction. It's 2/8. So 8 goes into 22 times. 2 times 8 is 16. Remainder 4. Bring down a 0. Okay, so he did h is 18. Oh, well, this is hours. Is that right? Did I make it that hard? Okay, so it's 18 and 2/8 hours. I'd rather put 18 and 1/4 hours than 18.25. And the reason I would rather do that, because I put 18.25 and some of you are going to put a dollar sign. But that's not what we're finding. It said h, how many hours did he work? He worked 8 1/4 hours, if I did my math here correctly. Try the next one. All right, tree has grown 24 feet in 3 years. So that's the rate of growth. He grew 24 feet in 3 years. it's growing 8 feet every single year. So our coefficient for y for years is 8. It was 8 feet tall when it started, when it was planted. And it's now going to be 61 feet tall. Subtract 5 from both sides. 8y equals 64. That one comes out much nicer. And so y equals 8 years, right? Words problems have words on their answer. All right, so the water here is leaking down, is leaking out of the tank, and so the water level is going down. All right, how fast is it going down? It's going down 2 meters per hour. That's our rate. So it doesn't say what to use as the variable. So, but we're going to do m for meters, how many meters it is. All right, so it's going down 2 meters per hour. And it started at 20.8, and we want to know when it's going to be at 8.2. That's the equation, right? Whenever we have that negative coefficient, the biggest number is not going over there anymore. Now, we're going to subtract 20.8 from both sides, and you get negative 2m. Now, you cannot do this subtraction this way, right? The bigger absolute value has to go up top when you actually do subtraction. Now, one thing you can do, well, let's just do it this way. 8 minus 2 is 6, and borrowing, and 2, and we get 12.6. So negative 2m equals negative 12.6, right? Because the bottom number was actually more of the negatives. Divide both sides by negative 2, and m for meters equals what? 12.6 divided by 2 is 6.3, right? I went a little fast there, but it's 6.3, or 6 and 3/10, 6.3. And this is meters, it's not hours or anything, so the decimal is fine. 6.3, oh no. Oh, I'm so mad at myself. And it's not m for meters, it's h for hours, right? It's meters per hour. Sometimes Mr. Ben messes up. All right, so it's h, it is hours. All right, so it's 6, and so it's 6, and 12 goes into 6 and 3/10 hours. Is that right? This is 12.6, and 12.6 divided by 2, and yeah, 6.3 hours. I don't really love that. Because what's 3/10 of an hour? 3/10, an hour is 60 minutes. So that's 18 minutes is what that is. 6 hours and 18 minutes. Notice what I did. I took 3/10, I made it a fraction, and multiplied it times 60 minutes. All right, final question. So there's that hole drilling down. There's going to be one on the test like that. It messes a lot of people up. So you're drilling at 12 feet every 3 hours. 12 feet every 3 hours is down 4 feet per hour. That's our coefficient. And let's use h for hours again. And they're currently at 10 feet above sea level, and we're drilling down to 22 feet below sea level. That's our equation. Subtract 10 from both sides. Negative 4h equals negative 32. Divide by negative 4, and h equals 8 hours. Thank you.